Okay, so in this type of question, we have to know that anytime you have a circle and a point outside that circle, and then you draw tangent segments, so pretend that these segments like AB and BC were tangent to the circle, they're always going to be congruent. And a quick reason why is if you draw the radiuses from the center of the circle to each of those points, and then complete that and make that two triangles. Now, though it doesn't look like it, I didn't do a very good job of drawing this. Alright, those two angles would be congruent because they're right angles. These two segments would both be radiuses, so they're congruent. And that's a shared segment. So triangle ADB and CDB are congruent by hypotenuse leg. So that's why tangent segments from the same point to the same circle are always going to be congruent. So how does that help us? Well, in this question, if we know that this segment here is 3.3, then that means that that part right there is 3.3 for that tangent segments conjecture. And then you kind of work your way around the circle. Right? If this segment was 3.1, then this part of the segment from W to this tangent point here would be 3.1. So now, like, if this whole segment XW is 8.3, right? If we just subtract this part, we get that this part has to be 5.2. Which means this part right here is 5.2. Because, you know, X to this point to that point, they're tangent segments to the same circle. And then if this part right here is 1.2, then that part's going to be 1.2. Alright, and then you just kind of add up all these numbers. So you add like 1.2 plus 1.2 and to 3.3 plus 3.3 plus 3.1 plus 3.1 plus 5.2 plus 5.2. And alright, and all that comes out to 25.6, whatever units that's in.